Reliability enhancement. What we do in reliability enhancement, we just enhance the reliability of our component. Suppose we have a reliability of 0. 0.9 and we enhanced it to 0.91. So why we do this? We do this because we have to find out which is the lowest component, the component with the lowest reliability we have to work on. So the first thing that we have to find out is which is the component I have to work on, the component that has the lowest reliability. And the other thing what we find out is that how much delta R0 reflects on delta Ri of the components I have to increase. So we have, suppose, R of 0. We have a reliability R of 0 at time t. So when we enhanced our reliability, what we do, we enhanced it to t star at time t star. So what we get, R0 plus delta R0. This is the form that we enhanced. So by enhancing our reliability, we have to find out first that which is the component I have to work on, like the component that has the lowest reliability I have to work on, and by increasing delta R0, so how it gets affected on delta Ri of the component I have to increase. Like first, suppose we have the component delta Ri that I have to increase, that I have to work on. So how it gets affected. So first of all, what we do for that, we have a formula. We know that in series block diagram, we have the products of all the components. We do the product of all the components. So when taking the R0 plus delta R0, we have a formula R1 R2 times R3 times Ri minus n times Ri times Ri plus 1 times R of n. So when after enhancing our reliability to R0 plus delta R0, what we got, R1 times R2 times R3 times Ri minus 1 times this Ri goes from Ri plus delta Ri when the reliability is enhanced. So R and the rest is the same, Ri plus 1 times R of n. So the equation, by simple multiplication, we get R1, R2, R3, Ri minus 1, and this Ri multiplies with the whole term first, with the first part Ri and Ri plus 1 dot R of n, and the other plus sign here, and the rest we write as R1, R2, R3, Ri minus 1. See, Ri minus 1, minus 1, and delta Ri. This one delta Ri comes here, and the rest Ri plus 1 and dot R of n goes in the same way. It's as it is as it was. So we have another form to represent this whole equation, like we can represent this whole equation. It's a quite lengthy one, so we can represent it in this form also. So what we write now, delta R0 equals to delta Ri times the product from j going from 1 to n, and j is not equal to I. This I and j are not equal. So j going from, what is the limit of j? J going from 1 to n, j not equal to I, R of j. So this is the first thing that we find out. From this equation we got this. We enhance it simply. Not enhanced it like we just it seems so big and large. It doesn't suit our eyes, and so we put it like this, because it can also be written like this. Now what is the next step? Now what we will do, we see that We have to find out Ri. We have to find out the lowest component, the component which has the lowest reliability. So now what we will do from this, we will just take delta Ri, see delta Ri over delta R0 over delta Ri. This delta Ri goes down there, right? When it goes down there, we have got this term, this delta cancels out, and what it becomes now, R0 over Ri. See, R0 over Ri. So this thing becomes now like this. And what we find out now, what we have to do, we have to take this delta R0, again this equation delta Ri, and we have found the value of this, like R0 over Ri. We have found the value of this, so we keep the value of this, that is R0 over Ri, here in this equation, and we name it as equation 1. Okay, got it? We named it as equation 1. And we also find out that delta Ri is the lowest component that we have to work on. So delta Ri, we got this equals to, this equation can also be written like this, like delta R0. If you have to find out delta Ri, this equation can also be written like delta R0, and this Ri goes there and got multiplied with delta R0, and this Ro, it goes in division here, and we got this thing delta Ri as this. So what we find out now, that the second question that we were talking about was that how much delta R0 reflects on delta Ri. So now we got that when we we enhance the delta R0, so it gets the reflection on delta Ri in this way. So the equation of delta Ri becomes like something like this, right? Now we have to talk about that the thing that is valid when we have no constraints. Like we assume that this is something, we assume that we have no constraints. So when we have no constraints, what we got, see, this delta R0 becomes delta Rj times the product k going from 1 to n, k that is not equal to j. This j and k are not equal, and r of k. So this is the another equation of delta R0 when we have no constraints. We have no constraints. So when we have no constraints, we got the equation of delta R0 as delta Rj, and the product k going from 1 to n, and k is not equal to j, r of k. See, this thing and this one thing is the same. It's just here we have constraint. We have constraint Ri. Sorry. And here we are talking about when we have no constraints. So we get the term this. Now what is our part? We do same calculation like we did before, like this thing. What we did, we took the Ri over down there. So now we will take the delta Rj over down here. So where it is, yeah, exactly here, delta R0 over R delta Rj, and this thing becomes same as here. We cancel out the deltas and R0 over Rj. So this thing becomes this thing, yeah, that we do it before, and we are just repeating things. And what is the reason behind doing this? We have to find out delta R0 and delta R0. We have to find out it. So now we are here, there we are, yeah. I'll just ignore this thing in between, I'll talk about it later. So we got this, we got the value of this as this. When we got this, what we do now, we took the delta R0 equals to delta Rj, and the value that we find out here, R0 over Rj, we keep it here r0 over rj, and we name it as equation 2. The same thing we did, as we named this equation as 1, the same procedure what we did, and now again we name it as 2. So why we are naming it, I'll let you know this after explaining you. So we name it as 1 and we name it as 2, and now we are going to compare both these, because delta r0 delta r0, we have got the two equations for the same thing. So we are going to compare just to see that what we got the result by comparing both of them. So now equation 1 and equation 2, we just compare it. We write this one, delta ri into delta into r0 over ri here, and equals to, comparing is equals to, you know that, you must be knowing that, delta rj times r0 over rj. So it seems that r0 and r0, it cancels out, and what it remains, this thing in division, and this thing in division. Now I have an example for you for this thing, for this type of thing. We have a cost I and a cost j. Suppose, we are just supposing that it's just a kind of question. We are supposing that we have a cost of I and cost of j. Two costs are there, and it is not necessary that this is only the type of cost. It's not only the cost that is in money. It can be anything. It can be power, it can be energy, it can be anything. So it's not always the cost. So what we do, we take two costs, that is I and j, and what we did, we divide by ci, cost I, divide and multiply, cost j, divide and multiply. So by dividing and multiplying the cost I and cost j, what we got, here we see we have just multiplying and dividing, and these both terms are written here, and we are just multiplying and dividing. So after that we'll take this thing, the thing that is dividing, we'll take it to the right hand side. This remains the same, you can see that this remains the same, and this, the denominator, goes in the right hand side. And what we got now by doing this, what we did, we have ci and delta ri. What we got, ci, ri, cj, rj. So what we did, we cj and ci, cj and ci, cj, okay, wait a second. Oh yeah, exactly. Ci and ri, cj and rj. These both terms, we combine them. Why we combine them? See, we combine them like this: ci, ri, cj, rj. Because we have to separate this thing now. This thing goes in separation here, and the same part, the same, like look wise they are quite same, ci and ri, cj and rj, rj and cj, delta, this thing comes out, and these both terms, they comes in, you know, in numerator and denominator. Okay, so this is the thing that we find out. Now what we got the conclusion, that if greater than 1, then we have to select the component j. Means that if this value is greater than 1, so that means that when this thing, suppose ci and delta ri, is greater than 1, when it is greater than 1, so we have to select the component j. And when this thing is less than 1, say, okay, when this thing is less than 1, so what we have to do, we have to select the same part. We have to select this when this thing is greater than 1. So what we do, we select j, and when this thing is less than 1, we select this part. So I can write this for you. that I'm talking about means that when this part, see, I'm talking about this, okay? When this is greater than 1, so we select component J, and when this is lower than 1, so we're gonna select this thing, and the rest is this. What we find out is how much I have to spend to get starting reliability value. So how much I have to spend on this so that I can get the starting reliability value.